First Chain Abstraction Community Call. Crazy. Welcome, everyone. And yeah, if you haven't heard much about chain abstraction, basically just the idea that you can interact with all these blockchains without having to know the complexities of each blockchain, and you can do that all from one near account, and it's done through chain signatures, which are jointly signed through multi-party computation, and then these signatures are broadcast to the target blockchain you want to interact with. So if you've not been on a sort of a dev hub community call before, then this is how they normally go. We discuss what's going on within the given domain. We normally have some proposed topics, but we like to keep it free format, so a lot of back and forth. So if you're presenting, try and keep it open to questions and whatnot. But if you want to leave questions to the end of your presentation, that's fine. And everyone's encouraged to participate. We love that. Either raise your hand, speak up, or if you're not comfortable with that, you can just write in the chat, obviously. And so myself is moderating this call, with also Victor and Ludmilla helping out from DevHub. We're all developer relations contributors. And one last thing, this call is being recorded, like I said. So we'll get right into it. So we have all these proposed topics. So we've got Matt talking a bit from Proximity, then Ben from Mintbase talking about what they're doing over there. Then we have some presentations from hackers at ETH DAM. And then there was also some discussion I picked up on in the chat that we could maybe talk about these topics. And if there's any other topics, like Mike, you wanted, you seem to be talking a lot about like account abstraction with Ethereum. So if you want to hop on that, and just if anyone else is building some cool stuff, I'm sure we would all love to talk about that. So Matt, do you want to go ahead, please?
Hey, so scary sharing your entire screen, but I gotta show you my IDE. So I went the wrong way already. Here we go. So basically what I've put together is a little thing I call the MPC script. Let me know if this isn't large enough. Is it all right? Okay. So basically, this is just the README. It goes over the flow of chain signatures. It's sort of like an all-in-one kitchen sink example for hackers, where they can just start from chain signatures and just get their head around the concept. They can do a lot of different things here. There's commands to basically do things with Ethereum, Bitcoin, Dogecoin, Ripple, or XRPL. And basically they can do a lot of different things. So they can just do basic transactions. They can send ETH, send BTC, send Doge, send XRP. But the latest thing that I wanted to demo today, just to keep it brief, and just to show you that the underlying kind of, infrastructure of this MPC script kind of tool is very easy to kind of, install and just see some results right away. But I'm actually going to show you a little bit more complex example beyond just sort of sending ETH using chain signatures. So that example is going to be, down here, just in my terminal. So it's basically going to be, I'll make it a little bit bigger. It's basically going to be, I'm just going to check my environment variables real quick. I'll actually I'm just working on a even more complex example, which I'll explain in a moment, but there's just a little bit of error with it. So what I'm going to do is, here, I'll just clear this. So let's start from the top. So what we're going to do is we're going to call deploy, which basically is going to deploy an NFT contract on Ethereum, standard one, like a 721, totally normal. And then it's going to use chain signatures to deploy that. So it's sending quite a lot of kind of bytes to the Ethereum network, but that all just gets hashed and we get a signature for that. So it doesn't matter how large your transaction is or how many contract bytes you're sending. But as you can see, the tool, MPC script, it just kind of gives you the basic details. It's like, we're going to call this, we're going to call the MPC contract that's here. Tells you the bytes that it's going to deploy. I don't know about this Puni code. Somebody who's probably better at this stuff can tell me how to get rid of this on my setup. But I'm going to confirm this. So it's going to hash that, do the Ethereum transaction. It RLP encodes, hashes, reverses it for the MPC contract, and sends it off. So we're waiting for the response to get the signature. And then once we get the signature, it broadcasts it to Sepolia for us, and then it gives you the transaction there, right? So let's open that up, and we can just wait. It's pending. It's probably gonna, be indexing soon. No, it's successful. Okay, so there's a contract deployed now, created here, and also I think I do log it out for you here. Yeah, so same thing. So when you deploy a contract on Ethereum, I log out where the contract gets deployed. So why do I do that? Because the next step is we're actually going to do an Ethereum call, like a call method with some gas to actually do some sort of, state change on that contract. So what we're going to do is we have to specify which contract we're calling. So we're going to put in that newly created contract. So we're now going to call that contract. And there's already a pre-built argument in here to mint the NFT. Or to mint an NFT. So we're just going to go ahead and rip out an NFT mint now. Same sort of details. We're calling near first to get the signature. Once we get the signature, we're going to put it back together with the Ethereum transaction and broadcast it. But we're now calling this newly created contract. So let's just wait for this to confirm. And the MPC contract's pretty swift. I think it usually takes about 6 or 7 seconds. Okay, so that looks like it worked, but we'll go check it, verify on Sepolia. And it's indexing, so it's usually bound to be successful soon. So that made a state change. It minted an NFT into a particular address, okay? So let's double check quickly though. We called the function mint with the argument of this address. So this is an address, like this is a method call kind of like signature that I pre-built into this MPC script contract. So this address was pre-baked, and that's just a default so that's easy for people to test. So you're basically just throwing a bunch of NFTs into my test address. So anyways, we're going to look at that, and we're going to look at that for one reason. We're going to make a view call now from the MPC script contract. So now we want to view the balance of NFTs for that particular address. And once again, viewing the balance of with the argument of this default address here, that's all pre-baked in. So I don't need to add additional arguments here. But if I wanted to, I could go like this. I could go args, and I could do the classic, method, balance of blah, 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 blah. But it's already pre-baked in there. So I'm not going to do that. Oh, I left blank args there. So I mentioned I'm under the weather, so it's bound to happen. So here's the view result. View result 1. So once again, we're just doing a balance call to the NFT. We can mint another one, and we can view, and the view result will be 2, right? So we can see the balance of the NFTs go up. I could, at this point, if we want, I could take this, this address, and we can go, we're on Sepolia here. We can go to NFTs, and I can import the NFT. And I don't think I have the token ID. That's the contract. Oh, the token ID should be, I actually don't know if it's 3 or 4 or 5. So, or no, it should be token ID 1. Sorry, it's
the
a
one in your
new
transaction
token.
is 1. The one that in your scan link there is a token ID 1.
I can't hear the person who's speaking.
Oh, sorry. Token
I
ID one.
have previous ones, so let's just look at the previous ones. Sorry, guys. We can just look at these, and it doesn't show up in MetaMask very nice, but if you do view it on OpenSea, this is the NFT that I generated with, obviously with AI. So this was from a previous iteration of the exact same example. And that's my demo. So that's all I have to share right now. So once again, I'll go to the actual GitHub here for FPC script and just show you the README. It's all here in the README, and I've been updating this relatively frequently, like a couple of times a week, just to make it super clear. Here's the NFT example here. And I'm working on a new example. It's not quite finished yet, but what the new example will actually be using a near contract and then paying that near contract to call sign on the MPC contract. And the reason you would do this is that, for example, you would deploy an NFT contract through the proxy contract. And then if you want a near user to pay some arbitrary amount, for example, one near token to mint an NFT on Ethereum, you can basically do that through this proxy contract architecture. So we have a proxy contract on near that's checking a deposit value. If the deposit value is valid, it will call MPC sign, right? It'll call the MPC chain signatures contract, call sign, get the signature, return it to the client, who's now the near user paying, and then they can broadcast the transaction. They go over kind of to Ethereum, broadcast the transaction, and it's all good. We mint the NFT. So I'm going to stop sharing, and we can do some questions.
I know I have one. So you said that the contract call is sort of set in there, right? Like you can't change it to a different function call, right?
No, you can. You can change it by putting in --args. I just didn't want you guys to watch me painfully type JSON.
Right, and then that's serializing it into like the hex or whatever that is going.
It'll serialize it into whatever arbitrary Ethereum method call that you want to make. Yeah.
Right. Okay. Cool. Awesome.
Contract call. Yeah. So sorry if I hope the demo was clear. I'm a little bit out of sorts right now. Just I'm very ill.
Thanks for coming on anyway. So any more questions, or we can move on? Leave it for 5 seconds.
If you would allow me to maybe just explain one more time, I'd like to just go over why have a near contract that would call, the MPC contract to get a signature instead of just doing, chain signatures calls directly from near accounts and then getting the signature and then broadcasting transactions. It's actually really cool because you think of a near contract could be like a hub for things that you want to do on other chains. So this could be minting NFTs. This could be doing airdrops. This could be doing all sorts of fun activities on other chains. And what you do is you actually push the application logic into the near contract. So the requirements to pay for an NFT, it happens on near. So it happens in near tokens or in USDC on near. The logic happens on near. So for example, multiple parties could vote on a near DAO with what we know is better UX and lower fees. Multiple parties can vote on a near DAO, and then that near DAO can execute moving underlying USDC to a proposal on Ethereum, right? So there can be like this kind of cool synergy between chains, contract to contract.
Awesome. Okay, yes, thank you very much. So I think we'll move on to Ben then, up next, if that's all right.
Thanks. I appreciate the time.
Thank you.
Well, hello everybody. Unfortunately, I do not have a demo today and that is clearly outlined in my weak slides. I'm going to share my screen now. It would be really cool if I did have a demo, but I kind of feel like the thing that I'm trying to do right now is perhaps one of the holy grails in this thing that we're building at the moment, or at least that's what I've been referring to it as. So I'll share my screen and get started. And yes, you'll see my entire screen and an infinite number of copies of yourself for just a second. Great. So here we are. Can everybody see this?
Yeah.
All right. This is really clever title, Chain Abstraction Mintbase. So let's just get going. So unfortunately, there is no demo today, but I wanted to just describe what do with chain abstraction and why, specifically in Mintbase's case, but I mean also just for the ecosystem as a whole. I think I'll talk a little bit about some of the technical challenges that I've encountered, a few of the implementation details, and I guess just talk about the feasibility of what we're really hoping to do with this, and maybe provide a few resources in case somebody else wants to contribute as well. So what and why? I mean, what we're doing right now is we're adding EVM support to Mintbase Wallet, and we're trying to do this via Wallet Connect. For those of you who don't know Wallet Connect, I'll actually show a little demo later just to give an impression of like why I consider this to be the holy grail. The reason we're doing this is really, I think it's just Web 2 user onboarding. End users will not know or care which chain they are on. They really just want to connect to dApps and use them. So I think this MPC contract positions Near as a prime candidate for Web 2 user adoption throughout the entire blockchain ecosystem. Yeah, so this kind of started with something that, I mean, when the MPC contract came around a couple months ago, we built out this node library that has already been used by many people as a building block for the ETH Soul hackathon. This library here, I'll share a link to the slides as well as soon as I'm done. This is the repo here near CA. It has since, I mean, somebody, this YHL125 at ETH Soul shared this repo yesterday that made use of some of this code and really expanded on what is possible that I hadn't managed to pull together yet. So I recommend taking a look definitely at either one of these, but definitely this. It's pretty sweet. Right. So I just want to show us what is. I mean, maybe I should describe what is Wallet Connect. I mean, how many people are not comfortable with what Wallet Connect is, or is anybody at all not familiar with Wallet Connect? Okay. Well. In that case, so I mean, Wallet Connect is an interface between dApps and wallets. And like what we did with the first example that we did was to go to OpenSea and buy an NFT. And this example was done all through the CLI. And really, the more general thing here is to be able to connect to any Ethereum application and not have to manually integrate those dApps into your system. So what Wallet Connect does is provides this sort of API interface that if you can respond to these functions that it calls, then you can connect to that dApp and interact with it. And it's the application's responsibility to build the transaction data for you that you need to send back, and all you need to do is send back a signature. This MPC contract does exactly that for us. It spits out signatures. And so, I mean, the very first thing that we saw was signed transaction, and we saw a great demo of that today as well with that really cool command line tool. And the thing that this other project was done at ETH Sol. Signed message and signed typed data was done as well. So this MPC contract gives us these three components of the interface that Wallet Connect expects. At this moment, it's kind of unclear if it's possible or even necessary to implement the rest of these. Like Connect, I mean, I'm not a front-end dev, so it's kind of tough for me to tell like to what extent we need to do this. And these are just definitely not going to happen. So we just throw errors. And I mean, realistically, we put together all the necessary components for the interface. Struggle, like hurdle-wise, I think Wallet Connect is sort of bound to Ethers JS. And a lot of the ecosystem now is like insisting on using Veeam. So actually, I can show us a little bit later why it doesn't matter so much. It's just a question that remains unclear about this Connect, whether it's possible or even necessary. And so then there's also the Wallet Connect Smart Account Library. And this is where I think you talk about, or examples are like the safe, these multi-signature smart contract wallets. And I'll actually show a demo today. Not a demo, but just an example of like what Wallet Connect does and the reason that I even bring this up. Because I mean, for the most part, near wallets are browser wallets. They're not extensions, they're like browser wallets. And this is sort of analogous to the type of interactions that you would do through the safe interface, for example. So, and some other doodads that I just added here. Like, I mean, the MPC contract signs for externally owned accounts. I should probably add in here EIP 433, whatever it is. But I mean, I think one thing that I hope to do or should probably be done, at least for security purposes, is so the MPC contract gives you an account that is an EOA, and what you want to deploy, and you can use this great demo that we saw today. Deploy a smart contract account, making the MPC account the owner of that multi-signature wallet, and adding an additional owner for yourself, so that you know, if you decide you don't want to trust the MPC, this service, you can at least cut your account off from there. And additionally, I mean, I've been working or investigating a lot the gas relayer services. This is something we hope to, you know, build into the system as well, for a gasless future, at least from end users' perspectives. This is still being worked on quite actively at the moment. So I provide a few resources. This is a repo for Wallet Connect that shows all the web examples and how the wallets are integrated. So I mean, I've got a dummy, not functional implementation of basically making a near wallet look and act and seem like an EVM wallet just by implementing that interface. There's these repos that we've already sort of linked to earlier. The gas relayer example is just the near docs. It's a link to the near docs because it contains links to all the other relevant code bases. And this is just where I'm hoping to find the implementation of how Safe has done Wallet Connect to get some inspiration from the front end perspective of how to go about doing this. I believe that's it for slides, but I just want to show anybody who may or may not be familiar with what this means and why it's so important. So you've got some sort of a browser wallet here, and you've got this little front-end component. Oh, that's not great. You don't want to have an error occurring. But anyways, there's this little area here. This is the means of connecting your wallet to some Ethereum application. I chose this, for example. I'm not sure why, but so you want to connect a wallet. You're going to click on Wallet Connect. You're going to get some QR code, and you're going to go back into your browser wallet. You're going to paste that QR code, and now you have sort of relayed. You're now connected, and this would be the account that the MPC contract gives you. And over here would be like the Mintbase wallet. So one can imagine, and this is where you would build some transaction. Let's say I want to sell some of this for this. And well, there's this approval process. I mean, this is maybe also a near thing, but then, you know, the transaction confirmation appears in your wallet. and this is where you would provide the signature. So really, as long as we can, well, I don't have enough gas. Okay. Anyway, but yeah, so the connection is done via this interface, and what we can do, what we have, I mean, what is entirely feasible now that we have this MPC contract as something that spits out transactions is put a little wallet connect button into the Mintbase wallet, go visit an Ethereum app and connect your wallet via this thing. Right. I believe that's it for what I had to say. I hope I didn't bore anyone.
Do we have any questions to Ben or what he's building? No questions. Come on, make it exciting.
I got a quick question. Yeah, very cool example. In terms, because this is a big, like I know getting Wallet Connect, working with any part of the near side of the infrastructure is a big win and stuff. Is there plans to kind of open source some of this stuff? Like, do you see this as a thing that other developers would kind of leverage?
Right. So I don't know who exactly asked that, but anyways, yeah, I mean, I always opt for open source first. So everything I've been doing from the near CA library, and I mean, any opportunity that I have to do open source, it's always the first option on my mind. Sorry, there was just something that I forgot. The reason that I chose CowSwap as an example was that the way that those transactions are actually going through isn't the signed transaction method, but it is the signed typed data, thing that you want to acquire signatures for. So, I mean, just implementing those interfaces already is pretty sweet. And this is similarly for the off-chain messages. Off-chain signatures. Anyways,
So it's an off-chain signature that you then send on-chain, and then the logic and smart contract is able to recover and confirm the public key and stuff.
Yeah, that's right. So it would be CowSwap's responsibility to hold on to the typed data that it's sending you to sign, and then we send off and we just spew out the signature. They take the signature along with the order data, the stuff that was signed, and they will store that in their order book. And this is yeah, I mean, this is cool stuff, really. And yeah, so open source, yeah, I aim for open source first, absolutely. And I think the Mintbase wallet, I don't know if it's currently an open source repo, but like, I'm sure at some point that it will be.
We love all open source. So I think Kendall had some updates, but it seems like he can't join. But I heard that Mike, do you have his updates to share?
Yeah, I did get a message. I think he accidentally got kicked or something weird with Google Meet. But yeah, so it sounds like a huge announcement being that in the next couple of weeks, the security audit will begin for the chain signature contracts. And I think he also mentioned the gas relay contracts. So, and then, yeah, I went through a security audit as well. And it usually takes 2 to 3 weeks. And then you got to clean up stuff. So we're talking about a pretty, we're seeing a pretty good kind of timeline horizon here. So next couple of weeks, security audit begins.
Right. So up next, as you may have seen in the chat and on Twitter and whatnot, some of our DevRels were in Amsterdam, which is quite well known for like a security hackathon and privacy. And we had chain signature bounties there, and we had 12 submissions, all eligible. 7 of them were chain signature related, which was just amazing. So we've invited some of them to share what they have, what they worked on this call. And I just ask if you could try and keep your presentations under like 4 minutes or so. That would be awesome, because we have 4 people, 4 teams presenting here, and then we want to get into some discussion afterwards. So could 2FA go first, please?
Yes, sir. Yes, sir. Hi, guys. How y'all doing? I'm about to share my screen now, and unfortunately, like Matt and the others before me, I have to share my entire screen, so it's a bit scary. Okay. Okay. All right. I think I'm sharing my screen. I'm not 100%. And I'm prompted to sign a transaction. Okay. Cool. So I don't know how to get rid of this, so I'm gonna just push it down to the corner here. Anyway, okay, sorry. So over the, I was at ETH DAM, and I participated in the hackathon, and I built on near the chain abstraction parts, and I built 0x2FA, which is a Google Authenticator clone, or Authenticator, decentralized Google Authenticator. And the problem I was having is that I really like using Google Authenticator, but the problem is I also hate using Google Authenticator. And I hate it because I have to share my personal and private data with Google, which I don't really trust. So I built a solution during the hackathon, not just for myself, but for anyone that values their okay, I see a comment here. Okay, yeah, that's me. That's my name. Okay, so yeah, I built something that's not just a solution for myself, but for people that value their privacy just as much as I do. It's pretty simple. So let's on the left here we have my phone, and on the right here we have the admin dashboard settings. I'll also push this down here. Okay, so we'll start off by activating 0x2FA. We sign a transaction, sure. And then on my phone, I click on the little plus, scan a QR code, allow it, sure. And I scan the QR code. And on the bottom there, it says the domain has been added successfully. Very nice. Give it a few seconds, it will pop up there with the domain, the domain of the app. So give it a second. And yeah, maybe disconnect my wallet, connect it again. There we go. Cool. So we have Binance, and every few seconds, every 30 seconds, it's going to generate a 6-digit code. We can verify the codes. So this could be used for resetting your password, registering, signing up, all that sort of stuff. And there we go. We get the little green hue. Also, it's gasless transactions. So when I scan the QR code, obviously I didn't sign transactions on my phone, which is cool. So this is cool as it is. It's reusable, like a lot of people would be able to use it. However, I wanted to use near with it, so I built a multi-sig that uses chain signatures or chain abstraction, and using my 2FA codes, the OTP codes. So let's create a multi-sig here. I don't know, call it a trading account. And for description, my first trading account, sure. Create it. There's a QR code, so I'll go back to my phone, scan a QR code, allow, sure, scan the QR code. There we go, domain has been added successfully. Now it's redirecting me to my multi-sig. Okay, cool. So now we're at our multi-sig, and it's using deterministic addresses. This is my ETH address. I also funded it with some ETH, just to not be, just so it will make them a little bit easier. And we have test ETH here. We have test BTC, BSC, and some other chains. Obviously, there's no SOL. This is just like just looks cool. A few actions here. So we can mint an NFT, which is a contract interaction. We can also send ETH or send ERC20 tokens. For ETH, you can actually just send the raw hex data bytes. So in theory, you can just call any contracts or deploy contracts or do anything you want using this data field here. This mints an NFT though. So I deployed an address and this just calls a contract interaction. Click mint. Now I have to enter my code 834. Hopefully this works. I haven't tested it yet. And there we go. OTP verified successfully and it's sending the transaction. In a few seconds, we should be getting a confirmation. And here we are. Where's the confirmation? View here. Push to the side. Indexing the transaction. And obviously we didn't connect any of our wallets. We had to obviously sign a transaction, and that's because of I'm using Oasis. That could be fixed in the future, depending on if they decide to fix it or not. And yeah, transaction is indexing. There's other chains, so we can also do BSC. You can also mint an NFT, or we can send some ETH. Let's send some ETH. Why not? Let's go to my wallet, copy my address. Let's just send 0.001 ETH BSC BNB tokens. My current code is 369. Let's see if I'm fast enough. Not fast enough. Okay, we're gonna have to wait for the next code. Okay, 380.010. Confirm. Sign. Okay, cool. So what I did there was just send some BNB from one from my multi-sig to another address, and should go through. There we go. Open that up. Okay, you can see the value here. Actually, this one was a lot faster. So just send some value from the multi-sig to my personal address. And if we go back to the Sepolia, there we go. We minted an NFT, and now we have NFT ID 18. Yeah, I mean, pretty straightforward. Yeah. So if anyone has any questions, welcome that.
Awesome. I think we should probably, if we can ask questions in the chat so we can move on with the other presentations, or ask them towards the end once everyone's finished. I think that would be the best approach so we can move along. So could we have feedback next, please? Or 0x feedback. Are they with us? We'll give it.
Yes, can you hear me?
Yeah, hi.
Okay, awesome. Yeah, just let me set up my screen.
Whilst we're waiting, Ahmed, what did you find like most difficult with the hackathon and with chain signatures?
Okay, it was. I mean, it's obviously a lot harder for me. I just do it solo, so I had nobody else on my team, so made it a little bit stressful, especially towards the end. In terms of using Near, honestly, it was pretty smooth. It was pretty straightforward. There was loads of example repos and tools I can utilize, and obviously Owen and Ludmill was very helpful and with any questions that I had. So I mean, I didn't have any major blockers, which was very grateful.
All right. Can you see the video now?
Yep.
All right, great. So I'm firstly gonna play the demo, and then I'm gonna explain like the details of the project. Can you hear the sound, by the way?
I don't believe so.
Okay, 1 second.
Technical issues are always the worst.
It's okay. We will cut them in the post-pro.
Okay, can you hear it now?
No, I can't. Maybe
Okay,
you can do a voiceover.
Okay. Do you know if there's like other way to share it in the Gmint?
I'm not sure. Maybe we move on to someone else and you try and fix
All
it
right. Cool.
whilst. That sound good? Okay. Do we have Nevo as well here to present? I think I'm saying
Hello?
Hello, hello.
Can you guys hear me?
Yes.
All right, let me share my screen. I have so many tabs open, this is scary.
Yeah, at the hackathon.
Okay, can I just have my friend share the screen for me?
I think anyone should be able to screen share.
And can you show your screen? Okay, she's gonna show you guys the presentation. All right, so as you guys know, Nevo is an app that we made using MACI and Near protocol, where it's pretty much a voting platform made easier for people who are older. So it's more user friendly. As you guys know, MACI is a voting platform. It's used to make voting so much easier. So it's used to combine Near and MACI together, where let's say you want someone who's older to start voting using MACI, but they don't want to like go through the trouble of using blockchain or whatever. So so it's connected with Near. As you guys see, this is how Nevo works. Okay, so we'll go to the next slide. And this is a demo video. Do you guys need me to do a voiceover?
It's up to you. Maybe you want to explain what's happening.
All right, so what's going on pretty much is it's used. 1 second. Okay, well, guys, actually, I'll just wait. We can skip now, and I'll just wait for my friend to come because he can explain it much better because I'm not into the technical side more. So I hope that's okay.
So I think the idea was that you were creating chain signatures on Near, right, and broadcasting them to make the votes, and it was like private voting, right?
That's pretty much it.
Yeah.
And this is the roadmap of how it works.
Yeah, it was crazy how in the hackathon there was these teams made so many detailed diagrams in like such a short space of time because it was only a 48-hour hackathon. Some teams made some really cool stuff, like better than ETH Denver, which is a really long hackathon.
Yeah, and just to give credit to everyone in the team, this is our team. Thank you, guys.
Thank you. So I think I said this name wrong the first time, but it's secured Jamon, right? It's not Jamon, it's Jamon, I think.
Yeah, you're right. It's from Spanish, yes. Can you hear me? Okay, I will try to show my screen. Mhm. Can you hear? Okay, can you see my screen?
I can't see your screen. I'm not sure about anyone else. I can see
Yep.
you, but not your screen.
I can't see it either.
Oh. Okay, let me try again.
Too many technical issues.
Well, it's good thing that we have the technical issues with the Google Meet and not with the chain abstraction, which is very funny. Like we are experiencing more issues with old tech or like something that's been around for a very long time, when less issues with something that we are currently pushing. So it's funny.
Yeah, you think a bunch of engineers would be able to figure out how to use Google Meet properly. But apparently not.
We aren't there yet. Yeah, meanwhile, I've been putting like the links to all of the projects that just tried to present into the chat. So if you want to take a look on them, on their presentations, and their code is also on the links that I'm sharing. So yeah.
Okay, do we either have, right, someone's presenting here. Here we go.
Okay, let me see if you can hear the audio now.
Yes, and today we are presenting our project 0x Feedback, which is
Okay,
an
cool.
anonymous feedback system with some rewards as the benefits for the user who participate in the feedback. So companies can come to our platform and they will be able to get an API key, and then they can use our API to create some feedback polls. So they will be able to provide the contact information of the users, and the users who participate in the feedback will receive a call, and in the call they will answer some questions, and after the call they will be able to go to our platform and they will be able to claim some rewards. And this is like on multi-chain. Companies can decide on which chain they want to provide the rewards, and users just need to interact with one chain near, and they will be able to get the rewards on any chain using near chain selector. And yeah, so let me show you a small demo. So let's just put in one number because I don't want to create noise in this room. So this is my friend Ranjit's number, and we are doing a poll on Tesla Model X. So let me send this request. So this is a company API. Companies will be able to use this API. Now the request is sent, and Ranjit is going to receive a call.
I'm
calling about the Tesla Model X. How would you rate your experience with the
Okay, and now I'm gonna play the second video, but I need to share the tab separately. Okay, 1 second.
Yeah, I thought the survey where it calls you up was really cool. I've not seen that in a hackathon project before.
Okay, can you see the screen again? All right, cool.
Request is being sent, and now my friend Ranjit should get a call. So he is getting this call now.
I'm calling about the Tesla Model X. How would you rate your experience with the vehicle on a scale of 1 to 10, with 10 being the best?
7.
That's great to hear. I'm glad you've had a positive experience with the Tesla Model X. Could you please provide some feedback on what you liked or didn't like about the vehicle? I'd appreciate any insights you can share to help us improve the product.
I like the driving range.
That's great to hear you're happy with the driving range of the Tesla Model X. Is there anything else you particularly liked or disliked about the vehicle? I'd be interested to get your full feedback.
Nothing else, thank you.
Thank you for your feedback on the Tesla Model X. I appreciate you taking the time to share your experience. Have a great rest of your day.
And do you want to explain what happened after they submitted the survey?
Yeah. I'm just. I need to share the. Okay. Yeah. I think the screen is shared again. So the way it works is that when some company wants to request the feedback from the customers, they're gonna open our platform and they're gonna choose how many customers they want to target, and they're gonna either upload the list of numbers that they want to call, or they will request us to collect these phone numbers from some certain group of people. And then our automated AI agent will start to call these people one by one and collect the feedback. Each feedback is processed anonymously thanks to use of the MACI on the blockchain from the Ethereum Foundation. And when we're receiving the response, the user gets rewarded for each feedback that he provides during the call. And then I don't think I have the recording of that here, but he enters our platform on web, he logins through the Nevo wallet, and then he can receive the reward on any EVM network. And yeah, I mean, I think that's it.
Awesome, thank you. So I realize we're approaching the end of the hour here, and people probably have other calls or other places to be. So feel free to leave now, or you can stick around and see the presentation from Secured Jamon. And let's try and keep the conversation flowing in the group chat afterwards. It'd be great to see everyone's projects and thoughts asynchronously. So, and I'm gonna give a little bit of a shill now. You always want to shill an infinite amount of things on calls, so I will just shill our DevHub newsletter where all the updates will be. I've just dropped the link in the chat there, and I'll drop it in the Chain Abstraction chat as well. So yeah, thanks for attending, but we'll get on with the Secured Jamon one now.
Okay, so I can try to share my screen now. Okay, is it working? Okay, cool. Okay, let me introduce our project from ETH DAM hackathon, Secured Jamon. So what was the problem we tried to solve? Is that today, to make a swap of assets in different chains, we should use bridges. So it's a huge problems with them, like vulnerabilities, and that they're not standardized. So we tried to use near MPC functionality to make a bridgeless asset swap. So I just moved to our scheme. Okay, imagine you want to swap two kind of assets, like one of them in near and another one, in example, in Ethereum, like DAI tokens, but in example, it could be even NFT and any other asset. So to make a bridgeless swap, we create a kind of market contract in near where anyone could propose a deal and provide the asset in different chain. After that, potential buyer may accept this deal, receive payments in near, and it all will be in a single transaction. And after that, original seller of asset will be able to retrieve asset in different chain using MPC contract. When deal will be created and executed, our market contract will create a flag that buyer now is allowed to withdraw his assets in different chain, we are calling our market contract, which will be called MPC contract, to create a signature for this withdrawing. So the main point is that the whole deal is kind of atomic, and it's creating in a time when the second side is accepting the deal. So now we don't need bridges anymore. But during the hackathon, we had a problem with the last part. I think all participants of hackathon had this problem, because it's kind of challenging to call MPC contract from another contract, not directly from your account. And during hackathon, we didn't manage to make it work properly. But after that, we kind of a lot of examples. And today, in a first presentation, we also see an example of this, how it can be done. So after hackathon, we managed to fix this. It's kind of points to improve. I will not try to read them all. You can see presentation after. You can see slides after my presentations. Let's go to demo. Okay, it's kind of simple front-end. It's from hackathon. We have just a one page for seller and for buyer. First of all, seller should create his deal. Like he specified how many Ethereum units he have. And he can receive some NEO tokens in exchange of them. When we create deal, in this time we create derived contract in Ethereum for our market contract. So that's it for seller. We go to page for buyer. And here we should accept this deal and receive Ethereum address to withdraw. I just copy it. Okay, here we have nothing unusual. It's just a simple matching contract. Okay, and in the end, we can call get signature for withdrawing. And here we call MPC. But in this demo, it's not kind of working because challenge I mentioned before, it's not updated in our demo yet, but that's how it should work. Okay, thank you, everyone.
Awesome.
Nice. Does anyone have any questions for any of the projects? I think one of them, I think 2FA dropped off, but he put his Telegram in the chat if anyone wants to reach out. And I think he's in the Chain Abstraction group.
I'm curious what the so was it wallet selector that ultimately needed to be tweaked, or was part of the problem? I'm trying to make sure I understand what you ran into.
Sorry, could you specify the question again?
So you had a problem, and I think it was with wallet selector. I would love to understand the problem you ran into a little bit better.
So when we call MPC contract, in result we receive kind of signed params, but we cannot receive them easily if it's kind of nested transaction. It's not easy to get result of calling MPC.
So I think a lot of teams struggled with making the cross-contract call to the MPC contract from like the marketplace contract, which was the difficulty. But I think a lot of teams managed to actually sign the transaction and get a result, but not to properly receive the signed transaction like back on the front end to broadcast it. I think that's what you meant. And also teams were dealing with issues with like making custom transactions, not just like sending like tokens, right? Matt, if you're still here, were you looking at creating a cross-contract call to an MPC example?
That is the example that I am currently in the process of finalizing. So I have a near contract that calls MPC sign, but instead of taking the hashed payload, it takes the RLP encoded payload. So this is the payload in Ethereum, very specific to Ethereum, where method names are the very first, I believe, 16 hexadecimal characters or something. And what you will do as the contract owner of the near contract is you'll specify what is a public method for people to call and what the cost of calling that public method will be. And the reason why you have to do that is because once deploying this contract that can call MPC sign, you have to protect arbitrary calls to Ethereum. For example, calling contract methods of other contracts or arbitrary contract methods. You have to prevent those calls from not happening. I don't know if you kind of understand or follow that logic, but basically you have to lock down the publicly callable methods. So what I do is I decided to go for the low-hanging fruit in my example, which is to accept the RLP encoded method and to simply do a Rust string find, for that RLP encoded method name. And then once that passes, and then I check the deposit, which in my case, it's a constant deposit of 1 near token. And so basically, if the method name's in the public list of method names and you pay the deposit of 1 near, you can call, and once again, in my example, it's mint on an NFT contract. So that's going to be my example, and that's just to give you the rudimentary basics of how you would go about kind of architecting something. In the future, I may expand the example to take in the full Ethereum or EVM, transaction details. And then what we'll do is we'll just use like a Saturday JSON to kind of, crush that down and RLP encode it. But I'd have to look into like the Rust Ethereum tooling and stuff like that. I'm not really familiar with what's available there. I think there's an Ethers Rust crate. So it should be totally possible. It just needs a little bit of homework on my end. I hope that helps.
Yeah, please shield that example when it comes out. I know that'll be useful to a lot of people.
Coming very, very soon. Yeah, I just had I actually believe that I had it working just a week ago or days before I got sick. And then I tried to sort of set it up this morning, and there's some small issue. The signature is just not kind of recovering correctly, but I think it's in my code base on the MPC script. So it's something very small that I can fix.
Nice. Yeah, get some rest. Okay. I think that's all for today then. Yeah, please keep the conversation going in the chat if there's any other things we wanted to discuss, because I know we didn't get to go onto the discussion much. And yeah, sign up to the newsletter as always. Okay, thanks a lot.
Really appreciate your time, DevHub, and thanks for hosting.
Cheers, likewise. Thanks for coming to present. See you, everyone.